Hello everyone, we are Team ID 1814 participated in TIIC IADC 2015. First of all, we thanks to TI for giving us an opportunity to explore our idea. We will start an introduction first. We are from Rajaram Bapu Institute of Technology, Islampur, Sangli, Maharashtra. I am Ashwin Umaji Kamble.
Myself, Sir Chandra.
Myself, Vinod Balbuddhe.
Our project title name is Smart Robot Railway Crack. Problem identification. The principal problem has been the lack of cheap and efficient technology to detect the problem in railway track, and of course the lack of proper maintenance of railway, which has resulted in the formation of crack in the railway and the other similar problems caused by social elements which jeopardize the security of operation of railway transport.
Our aim of project is to calculate the time required for the particular gap on the railway track. So for that purpose we have used a just simple formula, that is distance is equal to speed into time. So for that purpose we have kept the speed of the robot as a constant quantity. That means we have not changed the speed of the robot. So it will be constant. That means centimeter per seconds. And while the time required for the each particular gap will be different. That means, say for gap first it will take time t1. So depend upon that time t1 and constant speed, we can calculate the distance for that first gap. So again for this second gap, we can calculate the time t2, and depend upon time t2 we can calculate the distance t2 for gap 2. So in this project we are not keeping robot stopping on particular gap. It will continually moving on the track, also while the recording the number of tracks as well as their detection time. So we have used a very simple formula, that is distance is equal to speed into time, while distance is kept constant and time is going to be measured on this LCD display with the help of internal timers of the MSP 430 controller.
Hardware implementation of smart robot for rail crack detection system. It is a 4-wheel drive robot. There are 2 motors that are directly coupled to the wheels. DC motors are used for the movement of the robot. DC motor converts the electrical energy into the mechanical energy. Now the issue is to control the DC motor to get the desired speed and torque. DC motor has a very high speed of rotation, which is generally not needed by a system. The DC motors are operated at 12 voltage. It consumes 1.2 ampere current, 1 ampere current. Now the next part is the microcontroller of a system, that is a Texas Instrument MSP 430 G2. It consumes low power and it is easily available in the market. It is mostly used for embedded application. We can easily interface with LCD and other ICs like motor driver L293 DNE. The next most important thing of a component of a project is L293 DNE. It is a Texas Instrument IC. It is used for control the speed and the direction of the DC motor. It is operated at 12 volt and 5 volt. Why we are using 5 volt mostly for enabling the motor, and for 12 volt for controlling the supply of the DC motor. And the next most thing is the LCD, that is JHD 162A. It is a 2-row 16 column. It is mostly used to display the signal received from the microcontroller. We are displaying the current time and the detection.
Our project we have used the technology of infrared signals. For that purpose we have used the sensors of infrared sensor. It includes the 2 diodes, we can say. One is photodiode, it is having IR principle, and another is IR transmitter. So we can have the small sensor assembly here. It includes the 2 pairs like this. One is the transmitter, another is receiver, and this blue box is having that the potentiometer. So by wearing this potentiometer pot with it is a preset, so we can change the sensitivity of that particular signals. And for that purpose, for our project, we have used these wheels of having a diameter of 7 centimeter, and we have to calculate the constant speed. So for that purpose, we require some formulas of mathematicals, while calculating the perimeter of the circle, we require a formula, that is phi d. So we can have the calculations like this. If our project having a wheel of diameter of 7 centimeter, then perimeter of that wheel will be equal to pi d. So 20/7 into 7, that is 27 centimeter will be a perimeter of wheel. So we need to find out the time required for one revolutions. So according to our observations, to complete 20 centimeter revolution, that is 20 meter perimeter of this wheel, we require 8 centimeter. So depend upon that, we can calculate the velocity. So velocity of this robot will be equal to the distance covered by the wheel in one revolution upon the time required for one revolution. So depend on, we can get the constant velocity. So velocity of this robot will be constant throughout the whole demonstration.
Again, demonstration of smart robot for rail crack detection system. We have prepared the setup for our project. The setup consists of track which is made up of thermocol and mounted on table as like that. Then the scale shows the distance in centimeter. Now the circuit consists of two ports which is used for the controlling the speed of the two DC motors, one reset switch for resetting the circuit, and one motor start switch which is used for the on off of the DC motors. Now when the power button is pressed, then the LCD display the rail crack detection system, and it will wait to press the motor start switch. Now when the motor start switch is pressed, then the LCD will display, the motor will run, and LCD will display the crack number, detection time, and the current time. The current time is continuously incrementing, and the detection time is incremented when the gap is detected. And the LCD shows crack numbers, current time, and the detection time. When we have prepared the track which consists of three gaps, one is at 30 centimeter, another is at 50 centimeter, and third one is at 80 centimeter. Now when the crack is detected, then the DT time is incremented and the crack number is also incremented, and the table shows the result of our projects. It consists of three gaps which is located at actual distance 30 centimeter, 50 centimeter, and 80 centimeter. And the second column of the table shows the measure time, actual measure time required to reach the respective gap. That is for gap 1 9 seconds, for gap 2 16 seconds, for gap 3 26 seconds. Now the distance is calculated by using the formula distance is equal to speed into time. We have calculated the speed of the robot by using the formula distance upon time. We have calculated the perimeter of the wheel, which is calculated by using the diameter of the wheel, which is 7 centimeter, and the time required to complete one revolution. So the speed is 2.75 centimeter per second. Now the measured distance can be calculated by using the distance is equal to speed into the time required. So the column 4 gives the distance, that is for gap 1 24.75 centimeter, for gap 2 44 centimeter, and for gap 3 71.5 centimeter. And the last column shows the difference in the actual distance and the measured distance.